Now here is question 8. Question number 8. Question number 8, you were given a question that I showed initially, and then according to the question it says that the tank contains 400 gallons of brine. So this is the gallon. This diagram here is representing the tank that contains 400 gallons of brine, and then we're told that initially this tank contained 50 pounds of salt. This 50 pounds of salt was dissolved in water to get the 400 gallons of brine. And then we're also told that pure water was pumped into the tank at a rate of 3 gallons per minute. So you need to note, we're told it is pure water, not brine, pure water. So the pure water does not contain any salt. And then when the solution is well stirred, it is pumped out at the same rate. Now what is being pumped in is pure water, but what is being pumped out is actually brine, that is a solution of salt and water. Now you're told to first find the differential equation and then find A of, that is the amount of salt at time t equals 0. I'm going to start with the last one. So let me start by defining the terms. So let A of t denote the amount of salt present in the tank at time t. Now, according to part B of the question, we are told to find A of 0. Now, what it actually means is the amount of salt when time equals 0. We're giving you the question that initially it contained 50 pounds of salt. So you do not need to think of any other thing else. The initial amount is just 50 pounds. Now the next part, which is A, is to find the differential equation that actually models the process that is going on here. According to the assumption for mixtures is that the rate of change of the amount of salt in the tank equals the input rate, which I'm going to call R in, minus the output rate, which I'm going to call R out. So R in here denotes the input rate of salt into the brine, while R out here denotes the output rate of the brine out of the tank. The quantity of water in this tank here is not reducing, neither is it increasing, because as it's going in, it's also going out at the same rate. But then the rate at which salt is entering the tank is actually 0. Why? Because this is pure water. It's just pure water. It doesn't contain brine at all. So therefore that simply implies that R in, so we have R in to be equal to 0. Now to find the rate at which the brine is coming out of this, a very good way to think about it is, since we know R out, which is actually going to be the rate at which the salt is leaving the tank, and the unit is lb per minute. So the formula that we are going to use is going to be lb, which is a very good way I used to explain this, times gallon per minute. So what we actually mean here is the rate at which the salt is leaving the solution, which is lb per minute, equals the concentration of salt in that tank. You can see in the gallon, the concentration per gallon times the rate at which the solution itself is leaving, not salt now, the solution is leaving the tank. So we need to fill this place and fill this place. But then we are given that the rate at which water is leaving is also equals to the rate at which the solution is leaving. So then we are given that the rate here equals 3 gallons per minute. So you need to watch here, you have gallon per minute here, you also have gallon per minute here. So you should fill this space here. So here is 3. Now how then do you find the concentration of salt in the water actually leaving the solution. Now, based on our assumption, we said at time t, the amount of salt present in the tank is A of t. So if at time t, the amount of salt present in the tank is that is at A of t, the amount of salt in the tank that contains 400 gallon. So this is pound per gallon. So a pound of salt is present in 400 gallon. But this one says per gallon, that is 1 gallon. So how many quantity of salt will I find in 1 gallon? So you need to cross multiply. So that will be A times 1 all over 400. So this is going to be the concentration of the salt in the solution. So that's going to be A all over 400. That will be A all over 400. So you're going to use this. When you multiply this by this together, you have 3A all over 400. So this is R out. Now to find the differential equation that is actually modeling the processes going on there would now be dA dt equals, since Rn equals 0, so that will be negative 3A all over 400. So this is going to be our differential equation, while this is the initial quantity of salt in the solution, and that completes the question. Now here you're told to check if this differential equation is linear in V. So the first thing you want to do is you want to rewrite the differential equation in terms of V. That is, as a differential equation in terms of V. And how do we do that? So in terms of V, this man here is going to have to come under this man here. So it looks like a normal differential equation. So you have u dv du. So now it looks as if v is the dependent variable while u is the independent variable, plus v plus uv minus u exponential u equals 0. So writing this in standard form, so since we know this is staying alone, we have u dv du plus, now here v is common, so you have 1 plus u into v equals, so we can bring this to this side, so we have u exponential u. Now looking at all these equations that we have, it has the three terms we have here. To determine if this is actually a linear equation in V, so you'd observe that looking at all this, when you look at the term here, and then you look at the terms here, and you look at the terms here, they are all functions of u. That implies that the dE is linear in V. Now for the second question, we're still using the same differential equation, but you're told to check if the differential equation is actually linear in U this time around instead of V. So to check if it is linear in U, this time around we are going to treat U as a dependent variable while V now becomes the independent variable. So how do we do that? So this, we're going to divide both sides by dV, and what we have is U plus V plus UV minus U exponential U. Then you have du dV equals 0. Now if you're going to compare this to the normal standard linear differential equation, the standard form of a linear differential equation in U should be like this, something like this. You have your A of V plus B of V du dV. This is A of V times U du dV equals, then let's call this, say, G of V. So in other words, if you're going to compare all this, if you compare them together, so this maps this to this is still correct. Now this is du dv, that's correct. Now what we have here is a of v is mapped to 1, which is still correct. But then what you'd observe here is the coefficient of du dv is supposed to be a function of v only. A function of v only. But what you observe is this is v, but then this contains u. So this is a function of u and v. So it doesn't satisfy the condition for linearity of a dE. So, and that implies that 2b or 2 is, that is, the dE2 is not linear in u.